Okay, so my first lecture here is going to be starting your first C# project. So we're going to focus on how to declare a variable, which is the most basic of tasks in any programming language. So first of all, like we learned before in the previous video, to start your project, you go to File, New, Project, and you wait for about 20 seconds. Windows, console application, put the location on your desktop. I will name this, I'm not going to keep this, so I'll just name it example. Example project, example solution. Okay, so console application, Windows, C# on my desktop. So when you create your empty project, it's going to create a code file for you with pretty much nothing in it. And it's also going to generate some stuff for you over in the Solution Explorer that you don't really need to care about. So you can ignore pretty much everything over here except for program.cs. So this program.cs is your code file. And you'll notice that these lines of code up here are kind of grayed out. Apparently, well, let me say, there used to be, in the older versions of Visual Studio, it didn't used to do this for you. A grayed out line means it's not necessary and you can delete it. There used to be a tool called ReSharper that you could get that would do that for you, but now apparently they've integrated that right into Visual Studio. So I'm just going to go ahead and delete those. So now it looks even simpler, and I'm going to hold Control and scroll up a little bit so that it makes my code bigger. So here I am. I want to talk just about syntax and logistics a little bit before we start, because if I teach you how to declare a variable, it'll take about 10 seconds. So I might as well use this video to explain some basics. So first of all, let me talk about the word syntax. When I say syntax, I'm talking about the grammar of the programming language. So just like a real language has a vocabulary and a grammar, a programming language also has a vocabulary and a grammar as well. We don't really use the words vocabulary and grammar. We usually say the lexicon and the syntax. So the lexicon is the group of words that the language understands, and the syntax is the rules or the grammar for using those words together. And we don't actually say words, we say tokens. So one word in the language is one token in the lexicon. So for example, that left curly brace right there is the begin token in C#, and the right curly brace is the end token in the lexicon. And the way the syntax works is for each begin, there should be a matching end, and they group together basically a group of related instructions. In this case, if we look at that and nothing else there, that right there is a begin and end, which marks the begin and the end of our program. So anything that I put inside of this begin and this end is going to be the instructions of our program. Right now it's empty, which means our program does nothing. So the first thing I'm going to show you is another aspect of the syntax of the language, which is called a comment. So anytime you put / like that, the rest of the line is going to be completely ignored and won't mean anything. So you can write anything you want. You can say something like, I will just leave this here. So it's just kind of like a note that you write in the code to describe something, or maybe to tell a joke, or really for anything. Comments can be really useful, or sometimes they can just be for convenience. So still my program doesn't really do anything. I will now actually do something, and the purpose of I guess I should say the way that a program runs is one instruction at a time serially. So if you have 3 instructions in your program, they will execute one at a time from top to bottom. And the simplest instruction that you can do in C# or in any programming language is to declare a variable. So what to declare a variable means is you want to store some information, and you're not really sure what the value is going to be, and that value might change. So for example, let's say I'm creating a piece of software that keeps track of scores, or maybe some employee information or student information. I might want to store somebody's name. So what I can do is I can write a line of code like that, and that essentially creates a space in memory when the program is running for me to store a value. And that value can change. That's why they call it variable, because it varies. So this, I really want to. You might have heard me say before that I'm redoing my C# lectures. I actually have all of these concepts recorded in lectures already, but I think I went through them pretty fast, and I'm really going to try to slow these down and go into some of the details that I skipped over before. So if you feel like I'm talking too slow or going over things too slowly or dwelling on things too much, you might want to watch the other set of C# tutorials, because in these I'm really going to spend a lot of time talking about the things that before I was just like, oh, that's obvious, I'm not going to talk about that. So here, I'll look at this instruction, the only instruction in my program right now, and look at the details. So there's 3 tokens here. There's the first token, which is the word string, and you'll notice that that is blue. Now the reason it's blue is because the language understands what a string is. It's a keyword. It's a known word in the C# language, so we say it's a keyword. So keywords are marked in blue, and it's also a type. So I'll actually make another comment here. This is kind of the format of a variable declaration. You have a type, and then you have a variable name, and then you have a semicolon. So a variable declaration always follows this format. It goes boom, 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 type, variable name, semicolon. So in this case, the type describes what kind of information we're going to store in this variable. A string happens to be just a series of symbols, so it could be like hello, or it could be something like anything really, any bunch of symbols or characters. You can think of it just as a word. And there's other types of variables. For example, the other really common type is int, which is a number. So I could say, age. So now I have 2 variables declared, and this one is of type int, and this one is of type string. So the type aspect of the declaration is important because it's a rule for what type of information is allowed to be stored in that variable. So whenever it comes time to put a value inside of the variable and store an actual value, we will not be able to put a value in there that doesn't coincide with the type. So obviously integers are whole numbers with no decimal point. So 1, 2, 3. You can't store the value 3.5 in an integer because it's not an integer. If you tried to put 3.5 into that variable, it would either give you an error or just chop off the decimal place. You wouldn't be able to store an integer in this variable at all because it's a string, and vice versa. You wouldn't be able to store a string inside of an integer. So these are very specific about what types of values can go in those variables, and that aspect of this language, we call that a strongly typed language. So not all languages say, oh, you can only put this type of information in this variable. Some languages are very lenient about what you can put in there, and those are called loosely typed languages. So C# is a strongly typed language, so every one of our variable declarations is going to have a type explicitly defined. So the second aspect of the variable declaration is the name, and the name can be anything you want. It can be X, it can be be blah. It can really be anything. It can be blah1. It can be, you can make this as long as you want. There's really only two important rules. The first rule is that it can't start with a number. So you can't say 1 blah. It's going to be angry with that. So it cannot start with a number. We'll keep it name. Let's do something like this. Username and user ID. So, this isn't really a hard rule, but in general you want to give your variables meaningful names because, if somebody looks at username, they're going to be like, oh, well, I guess the username is going to be in there. That's useful information, and readability in your program is very important. If they look at it and it says X, they might be like, well, okay, there's a variable called X. I really don't know what's going to be in it. So that's not good. What was the other thing? Oh, you can't have spaces in a variable name. So it's one continuous string of characters there. So, and the final part of the variable declaration is a semicolon. And a semicolon marks the end of every instruction in C#. So no matter what you're doing, a semicolon marks the end of the instruction. The only time a bit of code, if you will, or a chunk of code doesn't need a semicolon are when it ends with a right curly brace, because a right curly brace by definition is the end of something. So to put a semicolon after it would be redundant. It's like saying it's over and it's over. So if you have something like this where it's pretty much defining the beginning and the end of my main program, this isn't an instruction. That's kind of a grouping of code. But each individual instruction inside of the grouping of code has this semicolon at the end. So I guess I will say be very careful of when you're declaring variables. I know this is the very first lesson, and it's the most basic skill in programming. But still, I always see people doing things like this, or trying to declare a variable with a space in it, and you're not going to understand why. Usually because whenever you get a red line like this, it's going to give you some kind of really inscrutable error message. It says it expected a semicolon. The name CERN. See, it's getting all confused by that one, and in the result of the confusion from the compiler trying to read this bad variable name is that it's giving you a cryptic error message. So, really pay a lot of attention to the details of what you're doing, and remember that the variable declarations have to follow this exact format. It has to be a type, which is a known type of C#. It has to be a name followed by that, and then it has to end in a semicolon. So as far as types go, we're really only going to be using, excuse me, I think we'll use strings, we'll use integers, and we'll also use bools. So bool is good. I'm not going to go into the setting the values in this video because that's the next one, but in general, strings store like words or sentences, and integers store numbers, whole numbers without decimal points, and booleans store one of two values, true or false. And oh yeah, the one other type of variable we'll use is double. So double would be something like weight, or white. Wait. So a double is like an integer, except a double can have a decimal place. So if you had the number 2.56, then you could store that in well, in my case right now, I think I weigh 197.6 pounds, so I can put that number in the weight. I think that might be it. There is it. Either in this video or the next one, I'm going to talk about debugging. Well, I might as well start now. So let's talk about actually running the program. And like we showed in the last one, to run the program, this program isn't really doing much. It's declaring four variables and then not doing anything with them. But you can still click Start up here. If I click Start, I should see my console window pop up and go away. So So my program ran, and I think I want to take this point to tell you that you can debug your program. So let's start off simply at least introducing the concept of debugging. What debugging means is you want to actually kind of pause it while it's running and see what's going on in there. So what I'm going to do is I'm going to put a breakpoint right there. So what I just did was I came over here into this gray column on the left, and I just left clicked it once, and it created a dot there. That red dot is what's known as a breakpoint. What that means is when it hits this instruction, and this particular instruction is the beginning of the program, it's going to stop, and it's just going to wait. And during that time, I will be debugging my program. Now remember, until you run the program, nothing is actually happening in memory in the operating system. There's no process running. So if I go to my processes here, processes, where are you? Oh yeah, I'm looking at them. And so I don't see anything really that interesting going on here. I see my Bandicam, I see my Microsoft Visual Studio, I see my Google Chrome. However, if I now run my program, and again, there's two different modes of running the program. One is release and one is debug. You can't debug it if you're running it in release mode, so let's just leave it at that and say make sure that it always says debug, and it probably always will. So if I put my breakpoint and I hit start while I have debug selected, so now notice it's kind of frozen on my breakpoint, and my black console window, which before just like appeared and then vanished, is now just like sitting there staring at me. And if I go over here into the task manager, I now notice this process here, which actually is my program running. So this process right here, if I come back over here and I say, you know what, I changed my mind, just go ahead and stop debugging. Now my program's over again, and I go back to my task manager. That Visual Studio host 32 is now gone. So keep in mind that while your program is running, and hence while you're debugging, your program is an active process running in Windows memory. So having said that, when I press start here in debug mode, my process is running. I have the ability now to manipulate that process, create memory in the process, which is exactly what declaring variables does. It creates memory that you can access and set values to within that process or program. And the cool thing is if I come up here to view, and there's some, or is it debug? Yeah, debug windows. So in this context list, debug windows, there's a whole tons of views that you can use to look into your process, look into your running program, and see what's going on in there. The one you're going to care about the most is locals. Locals will show you kind of all the variables that you're working with right now. So if I click locals, this little window pops up at the bottom, and I see all four of the variables that I declared. So these variables are actually active memory that exists in the Windows process that's currently running. And we can see that they all have these kind of default values. The string is null, which means there's nothing there, absolutely nothing. The two integers, or the two numbers that I declared, the integer and the double, they both have default values of 0, and the boolean that I declared has a default value of false. So I just wanted to start off with, again, show you how to create your first Visual Studio project, to be able to declare variables using these four types, understanding what the rules are for the syntax, what you can name them, what the semicolon is for, what these curly braces mean, and also just how to set a basic debug breakpoint, and understand that when your program is running, it's a process that is running in Windows memory. One last thing before we stop is that a lot of people, sometimes they'll be debugging, right? I'm debugging right now. So my program's running, it's frozen on this here, and people will go in there and they'll start trying to change their code while they're in debug mode, and they'll try to run their program. And what I'm saying is, be mindful of when you're in debug mode and when you're not, because you shouldn't be changing your code when you're in debug mode. You shouldn't be really doing anything except stepping through your code. So The surefire way to tell is to look up here, and if you see this stop debugging button is not grayed out, then probably want to stop debugging before you try to make any changes to your code. Alright, so that probably took a little longer than it should have, but at least I got some of the tedium out of the way, and in the next video we'll get right into assigning values.